So this was a weekly pop quiz 2. Again, it was related to the same topic, moles and acid, as we completed that topic 1. The first one, oxygen is vital in treatment of respiratory diseases. Oxygen is traditionally produced by fractional distillation of air. So just one difference between a fractional distillation of air and a crude oil. How they are different from each other. Basically, first what happened, air is a gas. So first we cool down air, and first we convert into liquid, and then we do a fractional distillation. So the main difference is there that air is a gas, or air is a mixture of gases. So first we convert gases into liquid, and then we carry out a fractional distillation. That's the main difference. But in a crude oil, like it's already a liquid, directly we do a fractional distillation. Hospital patients sometimes need to breathe air with a higher than the normal concentration of oxygen. The oxygen concentration can be increased to 90% by passing dry air through a tube filled with a zeolite, which absorbs most of the nitrogen. Dry air contains 21% of oxygen by volume. The average human breath has a volume of 500 cm3. Calculate the volume of air in decimeter cube that would have to pass over zeolite to obtain 500 cm3 of a gas, which contains 90% oxygen by volume. So what actually happened, like we can change the concentration or amount of oxygen to 90% when we pass the air over a substance called zeolite, which has a tendency to absorb nitrogen. So the question is, what is the volume of the air that must pass over a zeolite? So we get 90% of oxygen by volume. Like if we want to obtain like 500 cm3 of a gas containing 90% of oxygen. So how to do this question first? So first what we do, we find like what is a 90% of 500? Because if I draw a figure here, say this is a tube which is having a zeolite and air enter, because the question is calculate a volume of air passes over zeolite. So air enter, but then what happened? Most of the nitrogen is absorbed by the zeolite. And here we get 90% of oxygen. If we have the total volume of the air which is coming out, or total volume, why did not say air here? Because a specific composition is there for air, but this gas does not have, it's like 500 cm3 of a gas is coming out. So 500 cm3 of a gas which contains 90% oxygen. So we want to find what is the volume of the air which enter. So first we find how much oxygen should be there. Like 90% of 500 is oxygen. So 90% of 500, how to work out the 90% of 500? So it will be 90 divided by 100 into 500. So it will be 450 cm3. So means 450 cm3 of oxygen is there. So if there is a, like, if there is a 450 cm3 of oxygen here, how much oxygen is present in the air? That is also 450 cm3. Because oxygen amount is not changing. Only thing what changes is the amount of nitrogen in the mixture. So 450 cm3 of oxygen. So, and this 450 cm3 of oxygen is actually 21% of the air. So we have the formula like percentage of oxygen is equals to volume of oxygen in air divided by volume of air into 100. So what is the percentage of oxygen in air? That is 21%. What is the volume of oxygen? That is 450. Volume of air, we don't know. Multiplied by 100. If we need the volume of air, so what is the volume of air? It will be 450 multiplied by 100 divided by 21. This will give us the volume of air, but that will be in When we simplify, that will give us answer in cm cube. So this is about 2143 cm cube. That's a volume of air. 2143 cm cube. But we need the answer in dm cube. So we divide by 1000. So it will be 2.13 or 2.14 decimeter cube. So first what we did, we work out what volume of oxygen is there when it is coming out. And the same amount of oxygen will be present in the air. And that is the 21% of the total volume of air. So we work out the volume of air. But that is in cm cube. We divide the final answer by 1000 to convert into decimeter cube. Is it clear, this one? Any doubt in this part? Okay. The next question. Nitrogen molecule bind to zeolite using their outer electrons. Draw a dot and cross diagram of the bonding in nitrogen molecule. Nitrogen belongs to group 5. It's a covalent structure. So nitrogen share 3 electron. So 1, 2, 3. This also share 3 electron. And unshared will be 2. Unshared will be 2. This is a dot and cross diagram for a nitrogen molecule. Next is liquid oxygen is transported across the world. The liquid oxygen has a density of 1140 grams per decimeter cube. Just in exam, there will be a periodic table. Calculate the volume in meter cube. And that can be obtained from a bottle containing 13.9 decimeter cube of a liquid oxygen. So how to do this question? We have the density is given. Density, what is the density? Density is mass present in a unit volume. First, we'll find the mass, how to work out the mass. So mass is equals to density times volume. The density is 1140 and the volume is 13.9. This will give us the mass in gram, 15,846. So this will be 15,846 gram. Then, because we need the volume of the gas which is produced. So these are the mass multiplied by the molar mass to get the moles. So how to get the moles? Moles equal, like how to get the moles of oxygen. So moles of oxygen will be mass in gram, which is 15,846 divided by oxygen is 32. Because oxygen molecule will be there. So 16 multiplied by 2, that's make 32. So we divide this by 32. That will give us 495. Okay. So this will give us 495.5 moles will be there. And after getting the moles, we need the volume. So how to work out the volume? So moles equal volume of the gas in decimeter cube divided by 24. So we have the moles, which is 495.5. Volume we don't know for a gas, and 24 is divided. Other side will be multiplied. So 495 multiplied by 24. This will give us a volume, which is 11,884 decimeter cube. But we have to convert in the question they ask volume in meter cube. So to convert the decimeter cube into meter cube, you divide by 1000. So when you divide by 1000, you'll get 11.88 meter cube. Is it clear, this question? The next is total mass of a bottle is 80 kilogram when it is full of oxygen. Calculate the mass of empty bottle using your working from C1. Give your answer to appropriate number of the significant figures. Look, as we worked out this, what was the mass? We worked out it was like 50. This was a total mass. This was the total mass of oxygen, which is 15,846 grams, or you can also convert into kilogram. It will divide by 1,000, so it will be 15.846 kg. So this is the mass of oxygen. And the total mass of the oxygen plus the bottle is 80. So what you have to do, you just have to like, because this is a mass of the oxygen plus bottle, that is 80. When you subtract the mass of oxygen, which is 15.84, so you will get the mass of the empty bottle, which is 64, like 64 kilogram, 64.15 kg, or 64 kilogram. Then explain why the container need to be such a large mass. Like what is the reason why the container because what will happen, the container, it must have a, because it is holding the liquid oxygen, so, and the liquid oxygen due to a temperature may convert into a gas, and the pressure might increase as well. So the container must have a thick walls, so it can hold the high pressure. That's why mass must be more. Like if we use a container, because the mass of the container depends on the walls only. Inside it is hollow. So why it must be a thick walled container? Why the walls of the container must be thick? Like if we keep a liquid oxygen here, we keep a liquid oxygen, but why it must be a thick wall? Reason is that so it can withstand a high pressure or bear a high pressure. So the walls must be thick. And to keep the walls thick, the mass, because like we are using a metal for the walls. So if the walls are thicker, it means the mass is definitely, it will have a higher mass. So this was a pop quiz 2, which was related to moles and acids.